So these equilibrant problems add one new step. First, you have to know what an equilibrant is. We know that we add vectors together to get the resultant, and the equilibrant is equal and opposite to the resultant. It is what cancels it out. It has the same magnitude, but it's going in the opposite direction. It's 180 degrees away from it on whatever coordinate system you use. So the new step is very easy. If it's in unit circle, you either add 180 or you subtract 180. Only one of them is correct because only one of them will give you an answer between 0 and 360. So let's find the equilibrant for this one. The first step is to find the resultant. And because these are perpendicular vectors, this is a little bit more simple than what we've been doing. We redraw them head to tail, where x is 3, our y is 2, and we want to know our resultant and our theta. So our magnitude is 3 squared plus 2 squared is equal to c squared, and c is equal to 3.6. Now in order to find theta, we do tangent, TOA. Tangent of theta equals opposite over adjacent. So we do the inverse tan of 2/3. And we get that the angle is 34 degrees. So now we know that our resultant is 3.6 at 34 degrees. Because we can see if we put this in unit circle, that is already in unit circle. The equilibrant would be the vector that cancels out our resultant. So this is 34 degrees, and we know that this is 180 degrees. We would do 34 plus 180 to get that our equilibrant is equal to 3.6, because it has to be the same amount if it wants to perfectly cancel it out, at 214 degrees. So this information I wrote in blue is the only new step. Now the red part, the finding the resultant, can be far more complicated, like all the problems we just did in the type 2 or the type 3 problems. But the new step is very simple. You add or you subtract 180 degrees.